some problem from differential equation. This is a mixed problem set of 4 questions. So pause the video and give it a try. Let's see you in the solution in few seconds. So the solutions are given as in the form of timestamp. So you can click on the screen and go to a particular question, either 1, 2, 3, 4 or all of them if you have any sort of difficulty in solving the problem. So this is a mixed question, so it is not given which method to use directly. So we'll try for all the method, whichever clicks first we will solve that. So first question we have, that is dx minus xy into 1 plus xy square dy equals to 0. So clearly not looking like a variable separable form, neither homogeneous. So let's just try this by linear differential equation. So if we divide throughout by dy, so we are in the first question. So the first question, the equation is dx minus xy times 1 plus xy square dy equals to 0. Now if you divide throughout by dy, so you will get dx by dy minus xy times 1 plus xy square equals to 0. Okay, so this becomes just needs some simplification so that we can clearly see that linear differential form. So dx by dy minus xy minus x square y cube equals to 0. Now what we can do is to send this on the right hand side. So we'll get dx by dy minus xy equals to x square y cube. Now this is dx by dy, okay, and the format is something like this: dx by dy plus function of y into x equals to function of y. Now this is the normal form, but here we have an extra x square in the right hand side, which is not making it linear. It will be linear only if I will have this only x. So what I will do is to divide the entire equation by x square. So I will get 1 upon x square dx by dy minus 1 upon x into y equals to y cube. Now what we can do is to take minus 1 by x as t, differentiate both sides with respect to y. So that of minus 1 by x, derivative 1 by x is minus 1 by x square. So derivative of minus 1 by x will be 1 by x square. Derivative of x will be dx by dy equals to dt by dy. Okay, so this we are getting to be equal to dt by dy. So now this can be replaced by dt by dy. This minus 1 by x can be replaced by t, so we'll get t times y equals to y cube. Now we can find the integrating factor easily now. Integrating factor, because this looks of the form dy by dx plus a function of x into y equals to function of x. Okay, now can be interpreted in the form of y also, because here we have a different thing, but the integrating factor, because here you have got a function of y, here also function of y, so we can take this as like this, dt by dy we have. Now this, what was the standard form? Dy by dx, this was the standard form. Now in this particular form we take integrating factor as e power px dx. Okay, now why we take this function of x here? Because this function is present here also and here also. Similarly, y is present here also and here also. So the integrating factor will clearly be this thing, and since it is a function of y, so it will be dy. So e power integration of y dy will be y square divided by 2. So our integrating factor is e power y square by 2. Clear thing, not get confused. Whatever is it in both the sides, you know that will be your function, and take that function from here and e power that function. Whatever variable is there, integrate with respect to that. So integrating factor what we are getting is e power y square by 2. Now the solution will be t into integrating factor equals to this into integrating factor dy. So our solution will be as t into e power y square by 2 is integral of y cube into e power y square by 2 dy. Now we can take y square by 2 as u, differentiating both sides. So 2y power 1 divided by 2 dy equals to du, y dy equals to du. So our integral now becomes, you can write this as y square into y dy separate e power y square by 2. Now y dy becomes our du, y square will be 2u, and this becomes e power u. 2 can be taken out, u into e power u du. We can use integration by parts. First function as it is, integration of e power u is e power u minus integration of derivative of u with respect to u 1, integration of e power u whole integration. So 2u e power u, integration of e power u is e power u only. So this will get 2 e power u. If you take common, you will get u minus 1. Okay, and what was your u? Your u was y square by 2. So 2 e power y square by 2, y square by 2 minus 1. A bit lengthy. You can do this separately. So t. Now what was your t? T was your assumption, which was minus 1 by x. So we can now replace it. So minus 1 by x e power y square by 2 equals to, this whole integration giving us, we might take this 2 inside if at all we want. I don't want that. So 2 e power y square by 2, y square by 2 minus 1. So this can be plus constant c if you want. What as you can do is to take this term to the right hand side, and c or minus c doesn't matter. So finally what we are getting is e power y square by 2, taking common, okay, from this term. So you'll get 2 into this, so y square minus 2 from this term, and this gets added, so plus 1 by x equals to c. C goes that side, this term comes this side. So this is the final answer you are getting, e power y square by 2, y square minus 2 plus 1 by x equals to c. So this was all about this particular question. Now moving up to the next one. Now in the next question we are getting equation of the form m dx plus n dy. Why I am saying that? Because it's not looking homogeneous at all, neither looking easily variable separable. So we will go for the exact one because that is easy to solve. So let's write the question once again. So this is question number 2. Now clearly m dx plus n dy. So m will clearly be 2x cube minus xy square minus 2y plus 3. We do del m by del y. So you will get minus 2xy minus 2 from here. what is your n? We have done a 2 hour 40 minutes lecture on this thing, so that will help you. Now n is your minus of x square y plus 2x, so del n by del x will be minus 2xy minus 2. So since both of them are equal, del m by del y equals to del n by del x, clearly says that this is an exact differential equation, and directly we can move on to the solution, which is m dx plus n dy equals to c. Now what is your m? M is your this thing, integral of 2x cube minus xy square minus 2y plus 3 dx. And what about y? You have no term in what about n? You have no term in n which clearly have only y, so another constant term, so you can write 0 dy equals to c. Now x power 4 by 4, so this will become x power 4 by 2. I'm just doing integration with respect to x. This will become x square by 2, so minus x square y square divided by 2 minus 2xy plus 3x equals to c must be your answer. Now this is the question number 3 again, as because I am in the flow of exact, so I always think that every question needs to be solved by this. Let's try for this one also. So we can what we can do is cross multiply, so this thing into dx, so y plus x minus 2 into dx, this into dy, move that to the right hand side, so minus of y minus x minus 4 into dy equals to 0. Now you can send this minus side inside, so y plus x minus 2 into dx plus x minus y plus 4 dy equals to 0. Now what is your m here? It is y plus x minus 2, so you'll find del m by del y, which will come out to be 1. What is your n here? It is x minus y plus 4, so your del n by del x will come out to be 1. Since both del m by del y and del n by del x are equal, so this is clearly an exact differential equation, and in this case you already know the solution comes out to be m dx plus n dy equals to c. So what is your m? M is your y plus x minus 2, and from n take only those terms which have only y, so you have a 4, you have a minus y, dy equals to c. So xy plus x square by 2 minus 2x plus 4y minus y square by 2 equals to c must be your answer. Easy one. If you are facing any sort of difficulty, please refer to that video on exact differential equation. It will be all clear. So let's see another question. So we don't know which method to use, but it looks as if you use the linear differential once again, that will be handy, because first of all divide the entire term by x ln x, so you will get dy by dx plus 2 by x ln x into y equals to this divided by x ln x will be 2 by x. Now this is dy by dx clearly. This is clearly a function of x, so you can write that p of x into y equals to q of x. Clearly a linear differential form. So what you can do is to find the integrating factor, which is e power 2 upon x ln x dx. So this will give you, if you in this particular integral, if you look at this x ln x, a easy integral, because in this particular integral you can take ln x as t, so as to get 1 upon x dx equals to dt. So 2 dx by x is your dt divided by t, so 2 ln t is what you are getting. Okay, since this is log, so you can take this up, so ln t square, and now coming here, so t was your assumption, so this will be ln t was your ln x whole square, so e power ln x whole square. Okay, so now we are finally getting this. So we know a power log x to the base a. If you are getting something like that, you get finally x. So ln, that means log base e. So e power whatever is there. Here also we have base e. So whatever is here, that will be your final thing. So ln x the whole square will be your integrating factor. Now what we say as a solution, y into integrating factor equals to this thing into integrating factor dx. So y into integrating factor, which is ln x whole square, equals to qx was 2 by x into integrating factor dx. Now y into ln x the whole square equals to, now in this particular integral again, if you take ln x as t, so 1 by x dx becomes dt. So you're getting 2 outside, t square dt. So 2t cube by 3. So 2t was your ln x whole cube divided by 3. So 2 ln x whole cube divided by 3 plus a constant c. Now you can't make use of any of the properties of log because this is ln x whole cube. If you want to take this to the power, then that will also not work because this is the power of entire log x, not of only the whatever is inside x. So let's leave this solution to this position only. So you have done all the 4 problems which were there in this small test. I hope you enjoyed the video. Thanks and have a nice day.